indeed in the project background, data mining, text program, and you can still understand that we are performing. Well, first of all, this is the schema of the reconstruction. We are filing the environmental asset fatigue in pressurized components, and we are funding with the Horizon 2020 European Commission project with 4 million euros, and the construction is composed by 17 partners from around Europe and Korea, and we have 2 extra partners from the States that are Kepri and Naval National Lab. So what is the main objective of the project? It's increasing the understanding of the transferability between the lab, environmental asset fatigue test, and component scale that are submitted to this phenomenon. How we are going to perform this analysis, improving the mechanical understanding of environmental asset fatigue, performing of data analysis, data mining from the available data, the characterization of test specimen like battle workflows, and a specific test campaign designed to cover the gaps, and applying and all this knowledge should be applied to an industrial component in service conditions. Well, the justification for this project is like 10 years ago with these gaps that were reported by April. And the plastic release curves of fatigue life and with complex interment data to support the method, strain gradient, and data science. And they have another open question that it was about the component scale testing. And this is a topic not only in Europe, but we have many other different projects that are dealing with the same issue. That is, we have similar projects in Japan, United States, and other particular topics in France and Germany, and of course in United Kingdom. As I said, this is an open topic that is come from many years ago, and this INCEFA-scale our second step in this study, because we have this previous project called INCEFA+, where we perform more than 250 tests in area PWR in there to advance in the understanding of environmental fatigue. So in that case, we were focused on strain, the effect of the environment, and the sulfur efficiencies. One of the results was that we don't have this sensitivity either to main strain or to whole time. What we perform this specific test, and we get some different environmental factors. Another success was establish common testing protocol for all laboratories in the project, which is an important point if we want to compare different results. And we established this common format from fatigue data. What are we studying? So we have this Murex 6909 as a reference standard. This study the environmental in metals and water. So what we provide this standard. They provide us the fatigue light that is black line. And if you apply this environmental factor for 10, you got this reduction in the fatigue light that is the dashes line. And what we support and we observe in the previous project, and it's one of the hypotheses that the factor could be so conservative. So we can adjust the factor to get higher fatigue life in real components. Well, our project in INCEFA-scale, we started with a study of the data sets related with fatigue. And we collect this different data from many projects and many institutions. This previous study got the data from INCEFA+, the utility in Finland, USNRN, INL, and EPRI. We, with all this data from different institutions, we identify these gaps to cover in the framework of INCEFA-scale. For testing air, the effect of temperatures have to be bigger than a low strain rate. We found this lack of data at low temperatures and at low strain rates. And in the case of the environment of PWR, the effect of surface finishes appear to be bigger and lower strength. We identify another lack of data in significant low strength range with raw specimen and also a low temperature, and the waveform appears to have effect on the fatigue. So, continuing with this data analysis, we started with this independent project with this called International Fatigue Database, which is going to be a collaborative platform from institutions from around the world. And it's, well, we want to achieve this common condition or common data from this analysis of fatigue. So up to now, we have almost 5,000 data points. And in our case, it's interesting because we have this outstanding skill that have the largest population. So what we are learning with this in-time project. So produce more solid and reliable predictive models. New fatigue data we obtain through some knowledge graphs, and new evaluation tools is available for future evaluation. So this strength of data, so this could be the link to the website where you can find this model, and if you want, you can update your fatigue data set to try to test another models to estimate the fatigue. Well, in the test program, we have this hypothesis to investigate. The modified Goldman mean spread correction is already providing significant cover for the effect of the transition of mean spreads from variable amplitude to logging. And this is the reference for new 699 with a value of 1 or 2. The detrimental effect of fatigue or environmental fatigue factor and hardening might not combine literally, but instead can be dominated by an audience of the two. Variable amplitude loading significant radial strain magnitude during the rising associated the environmental factor to adversely affect on fatigue. And finally, the combination of variable amplitude loading and surface finish also the effect with the environmental factor. To cover this topic, we perform this kind of test with different variable amplitude. So in this case, this example is for a periodic overload, and we use this common material in PWR 399. The test was performed at R, room temperature and 300 degrees and PWR environment. We perform this following this previous protocol I mentioned and the standard fatigues, and we have this periodic overload, underload, over and underload, and high load interactions. Well, the current status for this test campaign is well, finish the first phase of this campaign. We have different specimens, solid, fluid, we have these different environments like PWR. And up to now, what we have shown is that with this periodic over and underload test, we have this effect on this higher fatigue life. So we have this influence on the fatigue environment. But we have performing another specific test that could be used for the industry and for studies two-component scale test. And in the same condition, we are studying this better script that in multi-area, this inclusive from a specimen, hollow specimen, and not well, you know, this not this quite common in component. So we have to look for this definition of strain at the node tip, and we are applying this strain in the environment. So up to the moment, all tests that we perform have a higher latent structure. And okay, now we are working in reviewing this strain measure in case we have made any error. Just to mention another kind of specimen that we are performing is this hollow specimen, where the environment is not is an limit of the specimen. And in this case, it is similar to pipe in PWR. Of course, we have this higher. So it's in the same way that we think that this environmental factor is going to be so restricted. Another important topic that we are performing is this analysis of mechanistic understanding and by analyzing of the fracture surface. So what information we are going to perform from this analysis? So estimate local propagation rate, estimation of applied loading and the specificity factor, estimation of the number of loading cycles that cause the failure, and reconstruction of the processing history. And what is the shape and appearance can provide indication of dominant propagation. Well, this is an example of one specimen that has this crack path propagation in the middle of the specimen, and all these crack growth rate that we can find along the cross section. Another part of this mechanistic analysis is the study of the formation in the canal. So what we have found is that there is so many locations where we have in the environment, and this deformation layer formation as much as facility accelerate the observation of material. This introduces some distribution. And another important point is that we are blocking the passive output pin due to the traffic deformation at the So what we are achieving for now, we have this strong collaboration with every NNL that should conduce to study all these phenomena in a component scale test. We have this data mining activity, and we have funded this international fatigue database. The testing protocol and the testing campaign is already going on, and we have how many results now in INCEFA-scale. We have defined the performance testing of follow nodes and multi-axis tests. Modeling is going to be supported by the analysis of fracture surface. We have this analysis of crack growth rate and specific factor, and we have the application. We are studying how to apply this knowledge to an industrial case and any other standard for example, in